Last time was 7 and 8. All right. So it says for me to list from your number 2 above the anion. Oh, no. No. I want you to go back to number 5 and 6. But then we talked about 7 and 8. So I'll leave it as is on the screen though. Okay. Question number 5 said to list your 6 cations that are neutral. Mariah, what are those 6 cations? And without looking at your paper, do you know who those 6 are? Okay, do you know your 6 strong bases? Okay, so take the OHs off of your strong bases and tell me then who those 6 cations are that are always going to be neutral. Okay, hold on. Okay. Never mind. All right, yeah, I'm ready. Lithium, sodium, potassium, calcium, strontium, barium. Okay, those are the 6 cations that are always neutral. Now I got to tell you a little tidbit. We kind of lied a little bit, and that's because AP exam has taken off RBOH and CSOH. Look on there right under K. You see RB and you see CS. All right. They technically are also strong bases, but the AP exam has said we so rarely use them, we're just not even going to have to memorize them anymore. So technically, there's 2 more neutral cations, and that would be RB plus 1 and CS plus 1, but we're not going to see them. Okay? So that's why we don't include them, because if we're not going to see them, we don't have to take the brain space to memorize them. But here are my 6 neutral cations. Kelsey, what about all other cations that I come across? Okay, they're weak what? If they're not neutral, then we only have 2 other choices if they're not neutral, either acidic or basic. So all other cations are what? Okay, all other cations are acidic. So give me a cation, Myreeth, then that's acidic. A cation. A plus charged ion. Vanadium? Okay, so vanadium plus 3. All right, so vanadium plus 3 would be considered an acid. And I know that looks weird, so you'll just have to trust me right now. All right, Michael, give me another cation that's acidic. Okay, Y. Okay. We'll just say Y plus 2, because any of those can be plus 2. Y plus 2. You don't know what that is? Uridium, but I don't know its charge. I've never seen it. I mean, all of those middle guys, generally all of them can be plus 2s, except silver. But everybody else supposedly can be plus 2s, because that's how many valence electrons they have, but I've never seen them. So y'all get some more traditional ones here now. Okay, Matthew, give me a cation. Give me a cation. Gold. All right, so we'll use gold plus 2. Gold. That's not traditional. Actually, give me a traditional cation. One that we see a lot. Zinc. Good. Yay. Yes. Abby, give me another cation, a traditional one that you see a lot, and you've been seeing it for almost 2 years now. Okay, chromium. And we could either have chromium 2 or chromium 4. I mean, chromium 2 or chromium 3. Okay. Brianna, one more. Manganese. Manganese or magnesium? Magnesium. Magnesium. All right. Now, you're going to look at those and go, how in the world are those going to be acidic? Aren't you? Are you? No. Okay, Kyle said, yeah. So why would you say to me, how in the world are those acidic? Because to be an acid, what do you have to do? Oh, this is crucial. This is laying that foundation. To be an acid, what do you have to be able to do? Okay, Austin. We got to rewind. Okay, let's just bring that back. In order to be an acid, what do you have to do? Be able to give away an H. You have to be an H plus donor. An H plus donor. Sometimes you hear that called a proton donor. Because a proton is H plus, because H plus has no electrons, so it's just a proton. Normal, regular, the isotope of hydrogen has one proton, one electron, so when he loses his electron, it's just a proton. So sometimes you hear it called a proton donor or a hydrogen donor, hydrogen ion donor. So in order to be an acid, you've got to be able to donate an H plus. So I was hoping you would look at all those and go, but how? I mean, like, I don't see hydrogen up there. So you'll just have to trust me so that we don't have to go too much deeper right now, that all of those will do something with water to get an H. Okay? They don't take away, but they complex to water, we'll leave it at that, so that they end up having some hydrogen in them. Okay? So we don't have to know the particulars about that anymore like I used to have to teach my students. So we'll just trust that those cations are acidic. But those aren't the ones we're going to see. Who is the conjugate acid of ammonia? NH4 plus 1. NH4 plus 1. NH4 plus 1. All right, there's a more likely cation that you and I are going to encounter. And that is why that one right there being the conjugate acid of NH3, that is why I asked you to list your cations from all of your amines that you wrote down as your weak bases. Because it's those cations we're going to encounter as being acidic. It's the cations of the amines. That means all the amines gain an H plus and become conjugate acids. And they're all acidic because they're all weak. Okay, so that takes care of cations. And yes, all of these are also acidic, but we're not going to encounter those. We're not going to have to worry about how in the world do they donate H pluses. They just do, so just trust me that they are, but we're not going to have to look at all of those. We will have to know about NH4 plus 1. Okay, now, next question. Alyssa. Back from the other question, it asked you to list your 6 anions that are always neutral. Do you know those? Yes, because you know your 6 strong acids. So tell me the anions when we encounter them that are always going to be neutral. Okay, good. They are all neutral. So all other Hayden, all other anions are what? All other anions, instead of being acidic like all other cations, all other anions are basic. Stephanie, except 2. There's 2 that are not basic that we're supposed to know because they have hydrogens in them. What 2? Exceptions. There's only 2. Except. What 2 anions out there do I have to memorize, and I do have to memorize it, are not basic but rather acidic. Skylar? Kyle? Kelsey? Huh? Yeah. Janae? Abby? Should give y'all a quiz on today. Nyree? Brianna? When Brianna doesn't know it, you know there's no hope.
What was the question?
There's 2 anions that are not neutral, and they're not like all other ones that are basic. They're acidic. Because they have hydrogens on them.
Mercury?
They have hydrogens on them. Water?
No, aluminum.
I gave them to you. Weren't y'all the ones that begged me the other day?
Yeah. Aluminum. Cobalt.
Are you sure I didn't tell you? Wait a minute. Wait. Am I really losing it? I didn't give you these the other day? Okay. Really? I mentioned them, but I didn't give them. Okay, good. Okay, I thought I'm not totally losing it. All right, I thought I had at least given you those. That must have been another class that said, please, please, please tell us the exceptions and write them down, and I did. Okay, so those are the two exceptions. So all other anions are basic. Did I just leave it at that last class? Okay, all right. So all other anions are basic except for those two. So here's what you get to do right now under your answers for number 9 and 10. I want you to create some salts that are acidic, basic, and neutral. This will really test the brain. Now, how many total would I like? Maybe 2 of each. I want 2 acidic salts, 2 basic salts, and 2 neutral salts. And what's a salt?
Metal or non-metal?
Well, it could be, yes, but it's just an ionic compound. And in regular chemistry, we kind of teach you metal and non-metal in the beginning, but then we get real deep. But it can be a metal and a non-metal, or it can be a metal with a polyion. It can be a polyion with a non-metal, or it can be a polyion and a polyion. So ionic compounds contain a cation and an anion. So go. Right now on your paper, I want you to use the brain. You to use your lists from number 5 and 6 and number 7 and 8. I want you to create right now for me 6 salts total, 2 of them that are acidic, 2 of them that would be basic, and 2 of them that would be neutral. This is where you really learn how to deal with your salts and learn your ions as to whether they're acidic, basic, or neutral. Go.